Okay, this is part 2 of 5.6. We're going to start with a triad. So you guys pause the video and find the vertical asymptotes and removable discontinuities of the graph. Okay, hopefully you found both the vertical asymptotes and the removable discontinuities. In order to do that, you should start by factoring to see if you can simplify any factors out. So x squared minus 25 is a difference of squares that factors into x plus 5x minus 5. In the denominator, an x factors out and leaves x squared minus 6x plus 5. That trinomial factors into x minus 5, x minus 1. Okay, so what we find is that the x minus 5's cancel, and that leaves x plus 5 over x times x minus 1. Alright, so for a vertical asymptote, we take the simplified denominator and we set that equal to 0. When I do that, that means that one of the factors, either x or x minus 1, must equal 0. So either x equals 0 or x equals 1 will be the vertical asymptotes. Now, because the x minus 5 was in the denominator and it is excluded, the x equals positive 5 is excluded in the domain. That means at x equals 5, at that exclusion in the domain, that is a removable discontinuity, which means there's a hole in the graph at that point, or at that x. So that brings us to horizontal asymptotes. So we approach those a little bit differently. We have rules to go with them. What we're going to do is we're going to compare the degree of the numerator and the denominator. So if you compare the degree, and if the numerator degree is less than the denominator degree, then the horizontal asymptote is at y equals 0. If you compare the numerator degree to the denominator degree and the numerator is greater than the denominator degree by 1, that means there's no horizontal asymptote, but instead you have what is called a slant asymptote, which again, we're not going to really jump into that in depth. Just know that there's no horizontal asymptote. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is at the ratio of the leading coefficients. So let's look at these three. So if we're comparing the degrees for g of x, 5x to the third minus 12 over 10x to the third minus x. The degree of the numerator is 3. The degree of the denominator is 3. They are equal. If they're equal, then the horizontal asymptote is at y equals the ratio of their leading coefficients. So their leading coefficients are 5 and 10. So y equals 5 over 10, which is the same as y equals 1/2. So there is a horizontal asymptote at y equals 1/2. For part B, the degree of the numerator is 2. The degree of the denominator is 1. The numerator is greater than the denominator degree by 1. That means there is no horizontal asymptote. There is a slant asymptote, but again, we're not going to jump too far into that. We're just going to stick with horizontal and vertical asymptotes. For the last one, the degree of the top is 2. The degree of the bottom is 3. 2 is less than 3, so the numerator is less than the denominator in degree. That means that the horizontal asymptote is at y equals 0. So you can quickly use the function to decide what the horizontal asymptote is, and then you can plot the horizontal asymptote on the graph as well as the vertical asymptote or asymptotes on the graph, and that will help you to graph the rational function. Okay, so you guys find the horizontal and vertical asymptotes of this function, and when you're finished, unpause the video and we'll go over it. Okay, so let's do vertical asymptotes first. First, I would check for any removable discontinuities to see if any of the factors will cancel. This has already been factored. Nothing cancels, so there are no removable discontinuities or holes. So we're going to set the denominator x minus 2 times x plus 3 equal to 0. So x minus 2 equals 0. X plus 3 equals 0. So there are vertical asymptotes at x equals 2 and at x equals negative 3. Alright, so now let's check out the horizontal asymptotes. Well, this is easier if we expand the numerator and the denominator. So go ahead and do the multiplication. So 2x minus 1 times 2x plus 1 ends up being 4x squared minus 1. The denominator, x minus 2 times x plus 3, and you would FOIL these. That would end up being x squared plus x minus 6. So we do this so that we can figure out the degree. So the degree of the numerator is 2. The degree of the denominator is 2. Because 2 equals 2, then there's a horizontal asymptote at y equals the ratio of the leading coefficients. So the leading coefficient in the numerator is 4. The leading coefficient of the denominator is 1. So there is a horizontal asymptote at y equals 4. And there are vertical asymptotes at x equals 2 and x equals negative 3. Okay, so let's talk about intercepts. So to find intercepts, it's mostly the same. To find the y-intercept, you set the zeros, you set the x equal to 0, or the x's equal to 0, and you solve. To find the x-intercept, you also set the y equal to 0, and then you solve for the x's. But because these are fraction, we can take this and note that since a fraction is only equal to 0 when the numerator is 0, because in order to get 0, you need 0 over a number. So when the numerator is 0, that's where the x-intercepts are going to be. So to find the y-intercept, set all of the x's equal to 0 and solve. To find the x-intercept, set the numerator equal to 0 and solve. So let's do that. So to find the y-intercepts, we substitute 0 in for x. And we get 0 minus 1, which is negative 1. 0 plus 3 is 3. 0 minus 4 is negative 4. We end up with positive 3/4 or 0.75. So the y-intercept is 0 3/4. Alright, now to find the x-intercepts, you take the numerator and you set that equal to 0. So for the x-intercept or intercepts, you set x minus 1 times x plus 3 equal to 0 and you solve. So we set x minus 1 equal to 0, x plus 3 equal to 0. We get x equals positive 1 and x equals negative 3. So we have the points 1, 0 and negative 3, 0. So those would be our x-intercepts. So y-intercepts are 0, or the y-intercept is 0 3/4, and the x-intercepts are 1, 0 and negative 3, 0. Okay, so this next try it, they want us to locate the asymptotes and the x and y intercepts. So I'm just going to go ahead and do this one with you. So it says, given the reciprocal squared function that is shifted right 3 and down 4, write the rational function, then find the x and y intercepts and the horizontal and vertical asymptotes. So we're doing multiple things here. So first I'm going to write the function. So f of x is equal to, it is the reciprocal squared function, which is 1 over x squared, but it's going to shift to the right 3. So if we're shifting to the right 3, we're going to subtract 3 before we square it. And then we're going to shift down 4, so that would be minus 4. So this is where we are recalling how we do transformations in the function itself. Okay, so now we have written the function, which was the first thing it asked us to do. So there's the function. So now we want to find the x and y intercepts and the horizontal and vertical asymptotes. So I think to make this a little bit easier, we are going to simplify this expression. So this is x minus 3 squared minus, in order to subtract the 4, we need a common denominator. And so the denominator that's common between 1, because this is really 4 over 1, is x minus 3 squared. And then to create that denominator on the 4, we're going to multiply the top and bottom by x minus 3 squared. So really I'm multiplying 4 times x minus 3 squared over x minus 3 squared, which is the same as multiplying it times 1, so I'm not changing the value. I'm just changing it slightly, not the value, but the expression, so that the denominators are common and we can subtract. So in the numerator I have 1 minus 4 times x minus 3 squared over x minus 3 squared. So I've run out of space there. I'm going to come down here. This is 1 minus 4 times x minus 3 squared. If we expand that, that's x squared minus 6x plus 9. I'm just going to leave this x minus 3 squared for now. It's easier to write that way. Then if I distribute the negative 4, I get 1 minus 4x squared. I'm distributing a negative 4, so that's negative 4 times negative 6 would be positive 24x minus 36, because 4 times 9 is 36. All still over x minus 3 squared. And that leaves negative 4x squared plus 24x minus 35 all over x minus 3 squared. And x minus 3 squared is x squared minus 6x plus 9. So I've simplified the function, or expanded it rather, to help me find the intercepts and the asymptotes. So to find the y-intercept, I'm going to set all of the x's equal to 0. So I'm going to rewrite the whole function, and everywhere I see an x, I'm going to replace it with 0. And this actually comes out to be negative 35 over 9. So I have a y-intercept at 0 and negative 35 over 9. Alright, so to find the x-intercepts, we take the numerator, negative 4x squared plus 24x minus 35, and we set that equals to 0. So I'm going to factor out a negative, and that leaves 4x squared minus 24x plus 35. And this one, depending on your comfort level for factoring, you might go put this in Desmos and find the zeros that way, and then go backwards and well, you're finding the x-intercept, so just put this in Desmos and see where it crosses the x-axis. So just put in this negative 4x squared plus 24x minus 35 and find the two zeros. But if you were factoring, what you could do is, if I have 4x squared minus 24x plus 35 equals 0, And if I divided both sides by negative, I would get this here. The way I like to do it, actually, I'm not going to do it that way. I don't want to confuse anybody. So what we do is we multiply the leading coefficient times the constant. So 4 times 35 is 140. So we want to know what can you multiply to get 140, but add to get negative 24, and it's going to be negative 14 and negative 10, because negative 14 plus negative 10 is negative 24. Negative 14 times negative 10 is positive 140. So I'm going to rewrite this as 4x squared, and then instead of the 24, I'm going to replace that negative 24 with negative 14x minus 10x. Okay, so now I have 4x squared minus 14x minus 10x plus 35 equals 0. And I'm going to factor by grouping. So that is where you group together terms that you know you can factor. So 4x squared minus 14 grouped, and negative 10x plus 35 grouped. We're adding those two groups together. And if I look at each of these, I can factor out a greatest common factor. So I can factor out a 2x from this first one, and that would leave 2x minus 7. And the second one, I can also factor out I think I can factor out a 5. But I'm going to factor out a negative 5 instead. Because if I factor out a negative 5, that leaves 2x minus 7, and now I have a 2x minus 7 in common. And so I can factor that out. I can factor out a 2x minus 7, and that would leave a 2x minus 5 equals 0. So, and we're doing all this to get the x-intercept. So we're going to set each factor equal to 0, and for this first one, we'll get 2x equals 7, so x equals 7 halves, or 3.5. And on this one, we get 2x equals 5, so x equals 5 halves, or 2.5. So we have the x-intercepts at 7 halves and 0, and 5 halves and 0, or 3.50 and 2.50. So far, we've found the y-intercept, and we found the x-intercepts. Alright, so what else did we need to find? We need to find the horizontal and vertical asymptotes. So for the vertical asymptotes, I'm going to take the denominator, this x squared minus 6x plus 9. I'm going to set that equal to 0 for the vertical asymptotes. So x squared minus 6x plus 9 equals 0. You hopefully see that it's a perfect square, which would be x minus 3 times x minus 3, which is x minus 3 squared. So either way, it's the same thing, just two different ways to write it. So if you write it this way, you set each of the factors equal to 0, and you get x equals 3 either way. If you do it this way, the way I have it written on the right, you take the square root of both sides, and you end up with x minus 3 on the left on the right, you get plus or minus 0, which is just 0, and you add 3 on both sides and you get 3. So either way, you get a vertical asymptote at x equals 3. All right, one more thing to go, and that is our horizontal asymptote. So we need to go back and see what our original function was. I'm going to go ahead and take where it was simplified right here. I'm going to copy that. I'm going to put it down here so I don't have to retype the whole thing. Okay. So I have this here so that we can figure out the horizontal asymptote. So for the horizontal asymptote, we take the degree of the top, which is 2, and the degree of the bottom, which is 2. We compare them. They're equal. If they're equal, then the horizontal asymptote is at y equals the ratio of the leading coefficient of the numerator and denominator, which is 1 on the bottom. So negative 4 over 1 is just negative 4. So there we have it. So now we have, let's write it all out. We have a horizontal asymptote at y equals negative 4. We have a vertical asymptote at x equals 3. We have a y-intercept at 0 and negative 35/9. And we have x-intercepts at 7/2, 0, and 5/2, 0. Which you could also write as 3.50 and 2.50. So there you go. There's all of it. That was a fun one, right? So now let's just talk about graphing. So to graph, you want to just identify those things that we talked about. You want to identify the y-intercept. You want to factor the numerator and the denominator so that you can find the x-intercepts and that you can find the asymptotes. And the removable discontinuities. And then you want to find the horizontal asymptotes. We're not finding slant asymptotes. And then you sketch the graph. So basically, my advice would be to find those main characteristics: the y-intercept, the x-intercept, the vertical asymptote, any removable discontinuities, which would be holes in the graph, and then horizontal asymptotes. Draw those horizontal and vertical asymptotes on the graph with dotted lines. Go ahead and plot the x-intercept and the y-intercept, and then go to Desmos so that you can see the local and end behaviors, and then you can just sketch the graph from there. So let's look at this last one here. This is our last example. Yay! So let's go ahead and find 4 things. Let's find we'll find the horizontal asymptote, the vertical asymptotes. We're going to find y-intercepts, and which there will only be one y-intercept, and then we'll find the x-intercepts. Okay, so horizontal asymptote. Let's look at the degrees. The degree of the top is 2. The degree of the bottom is 2. They're equal, so the horizontal asymptote is at y equals 1 over 1, which is y equals 1. So at y equals 1, I am drawing a horizontal asymptote. Okay, so then let's see, vertical asymptotes. We're going to set the well, actually, before we do that, let's go ahead and factor. So f of x is equal to, let's see, x minus 3 times x plus 2. And the denominator factors into x plus 2, x minus 2. So it looks like these two cancel, and that leaves x minus 3 over x minus 2. So that looks like there's a horizontal asymptote where x minus 2 equals 0. So there's a horizontal asymptote at x equals 2. So I'm going to, at x equals 2, I'm going to draw a dotted line and label that x equals 2. So what does that mean about the x plus 2 factor that had canceled out? So we can take the x plus 2 factor, set that equal to 0, and there's a removable discontinuity at x equals negative 2, so we will remember that there is a hole in the graph there. Let's see, so check. Y-intercept, we're going to set each of these x's equal to 0, so that's going to leave negative 6 over negative 4, which is 6/4 or 3/2. So there is a y-intercept at 0 and 3/2, which is the same as 0 and 1.5. So at 0 up 1.5, there's a y-intercept right there. So now let's find the x-intercepts. So to find the x-intercepts, remember you're setting the numerator equal to 0. We've already factored that. That factored into x minus 3x plus 2. And so we get x equals 3, and we get x equals negative 2. So x equals 1, 2, 3, and x equals... Alright, so I think this one's not going to be 1 because... And we'll just double check and make sure. I don't think it will be 1 because it canceled out. And it's a removable discontinuity there. So it can't actually cross the x-axis at x equals negative 2 if the graph isn't defined there. So the only 0 is at x equals 3. Alright, so now that we've got all of that plotted, then what I would do is I would go into Desmos and I would put in the equation. So I had, let's see, x squared minus, what was it, x minus 6. And then divide that by x squared minus 4. Alright, so you can see these points. At x equals 3, there's a 0. At 0 and 1.5, there's a y-intercept. You can hopefully see that the asymptotes. Here, let me do this. Let's do y equals 1. So you can see there's an asymptote there that the graph isn't going to cross. And then we can do x equals, what did we say that was going to be? What was the vertical asymptote at x equals 2? And so you can see that the graph doesn't cross in those places. So that can actually help you when you're graphing here. Like this, where it's going to approach 0. As x approaches infinity, the f of x approaches 0. As x approaches 2 from the left, x is approaching, I'm sorry, f of x is approaching negative infinity, and then you have the same thing as x is approaching 2 from the left, y is approaching infinity. As x is approaching negative infinity, f of x is approaching 0. So I think that my graph could be drawn a little bit better than that. Still not beautiful. Desmos is definitely better, but hopefully you get the point. So label these main pieces here, horizontal and vertical asymptotes, x and y intercepts, and then use Desmos to fill in the blanks. Okay? And that's all for this section. Email me if you have questions.